Welcome to Tomorrow Unveiled. And happy Tuesday. It is February 10th, 2026. If you've been following the headlines or even just doom scrolling while waiting for your coffee, you might have sensed a shift this week. The tone just changed.
It certainly did. In the history of science, we often look back at these specific weeks that acted as a fulcrum.
Right.
A moment where the theoretical finally tipped over into the actual.
Yeah.
And looking at the sheer volume of research our team pulled together for us, I genuinely believe we are living through one of those weeks right now.
Industry analysts are actually calling it the Great Inflection, which, I'll be honest, it sounds a bit like the title of a summer blockbuster movie.
It does have that ring to it.
But when you actually dig into the data, it feels like it earns the drama.
Yeah.
For decades, anti-aging was this fuzzy, slightly embarrassing concept.
Mm-hmm.
It was billionaires doing weird blood swaps in Silicon Valley or people selling $60 face creams that didn't do anything. It was sci-fi, or worse, snake oil.
And that skepticism was healthy, because the science just wasn't there yet. But this week, the conversation completely changed.
Completely.
We aren't just talking about slowing down the clock anymore. We are talking about reversing it. And we aren't talking about mice or yeast anymore. We are talking about human trials cleared by the FDA.
That is the headline that stopped me in my tracks. So, okay, let's unpack this. What does the Great Inflection actually mean for the person listening to this right now?
Well, to understand the technology, we first have to, I think, upgrade our vocabulary. The old model was all about lifespan, just keeping a body alive, breathing, heart beating for as long as possible.
Right.
The new model, the one that's driving this inflection, is functional life extension.
Which is such a crucial distinction.
Yeah.
Because nobody wants to live to 120 if the last 20 years are spent immobile in a hospital bed.
No.
That's not a goal, that's a nightmare.
Precisely. Functional life extension is focused entirely on the health span. It's about squaring the curve. You want to maintain high-level physical and cognitive performance until the very end.
So it's about expanding the prime of your life, not just tacking on frail years at the end.
Exactly. And the science dropping this week suggests we can actually do this by treating aging not as an inevitability, but as a loss of information.
Okay, this is the concept that I found most difficult to, wrap my head around initially. The information theory of aging. Our research team highlighted an analogy here that compares our DNA to a CD.
It's a classic analogy for a reason. Think of your DNA as the digital music burnt onto a disk. That information is permanent. It's the same digital code when you're 5 years old as when you're 80.
The song doesn't change.
The song doesn't change. But over time, life happens. The disk gets scratched.
And in this scenario, the scratches are what? Like lifestyle damage?
The scratches are epigenetic noise. They're chemical markers, specifically methylation tags, that accumulate on top of the DNA. They just gum up the works.
Right.
The cell's reader, the laser, if you will, starts to skip. It can't read the song clearly anymore. The music is still there deep down, but it sounds distorted. The cell effectively forgets that it's supposed to be a skin cell, or a liver cell, or a neuron. It gets confused. It gets inefficient.
And that confusion, that is what we call aging.
That's it.
So the breakthroughs we are seeing this week, this isn't about burning a new CD. We aren't replacing the DNA. It's about polishing the scratches so the original music can play again.
Exactly. It is a restoration project, not a replacement project.
Yeah.
And that brings us to the biggest story of the week.
The regulatory milestone. This is huge. Our research team reports that the FDA has officially cleared the first ever human trial for a partial epigenetic reprogramming therapy.
This is the polish we were just talking about. This is it in action.
Okay, but I want to get specific here because reprogramming sounds a little dystopian. How does it actually work? This isn't a supplement you pick up at the grocery store.
No. This is gene therapy. It's highly sophisticated. The research team explains that this therapy involves introducing specific proteins, often referred to as factors, into the cells.
Okay.
These factors act like a solvent for that epigenetic gunk we mentioned. They go in and strip away the accumulated chemical tags that are confusing the cell. They tell the cell, ignore the noise, ignore the damage, and go back to your original operating instructions from when you were 20.
Wow. Okay, now for this first trial, the notes say they are targeting the eye, specifically the retina and the optic nerve, to treat vision loss. Why start with the eye? If this is the fountain of youth, why not just inject it into the bloodstream and rejuvenate the whole body?
That is a great question, and the answer comes down to safety. The eye is what scientists call a contained system.
And
It has a property called immune privilege, meaning it's largely isolated from the rest of the body's immune system. So if you're going to test a powerful technology that resets cellular identity, you want to do it in a sandbox.
okay. If something goes wrong in the eye, it stays in the eye.
Exactly. It doesn't spread system-wide. It's the perfect proving ground.
That makes sense. But I need you to clarify something else because the term partial reprogramming keeps coming up in the source material. Why partial? If we have the technology to reverse aging, why not go all the way? Why not reset the clock to 0?
Because 0 is an embryo, and that is the critical danger here. If you do a full reprogram, a total factory reset, you turn the cell all the way back into a stem cell, a generic blob with no identity.
Oh.
If you did that to your retina, you wouldn't have a young retina, you'd have a tumor of confused tissue.
Which is definitely not the goal.
Right. You don't want your eye to forget it's an eye. You want it to remain a specialized eye cell, just a younger one. That's why it has to be partial. You polish the scratch just enough to clear the distortion, but you stop before you melt the disc.
A delicate balance.
A very delicate balance.
That distinction is vital. Okay, so we have the polish. But here's where I get skeptical. We've heard about curing aging for years. If we are treating this, how do we actually know if it's working in real time? You can't just give someone a therapy and then wait 50 years to see if they die.
You can't. It's a terrible feedback loop.
So how do you measure it?
It's the fundamental problem of longevity research. You need a speedometer. You need to know how fast you're going right now, not just when you crash. And that is where the second big pillar of this week comes in, artificial intelligence.
The Brainy 8 tool. I have to say, the name is catchy, but the claims are pretty wild.
They are, but the data backs them up. This is a new AI foundation model that our source material discusses, and it was trained on nearly 49,000 brain MRI scans.
49,000. That is a massive data set. But what is it seeing that a human doctor can't?
A human radiologist is looking for obvious pathology, a tumor, a bleed, a stroke. Brainy AC is looking for texture. It analyzes the microscopic degradation of white matter, slight changes in volume, vascular patterns, things that are invisible to the naked eye.
And from that, it can tell your age.
It can predict your brain age. So your driver's license might say you are 45, but Brainy ASIF looks at the deep structure of your brain and says, no, biologically, this brain is 52.
It would be a terrifying conversation to have with your doctor.
Or a motivating one. Because it goes beyond just age. It can predict dementia risk and even estimate tumor survival years before clinical symptoms appear. It's seeing the faint signals of aging in the noise long before you feel them.
This connects to another metric our researchers flagged called Dunedin pace. It sounds like a race, but from what I understand, it's more like a speedometer.
Exactly. Most age clocks just tell you are biologically 50. That's a static number. Dunedin pace tells you the velocity at which you were traveling toward death.
The velocity.
Think of it this way. Are you driving toward the cliff of old age at 40 miles per hour, or are you speeding at 80?
So if my Dunedin pace score is, say, 1.2, that means for every one chronological year that passes, my body is aging 1.2 years.
Correct. You are accelerating your own decline.
Yeah.
But if you can get that down to 0.7, you are effectively buying time.
And the goal of all these interventions, the diet, the reprogramming, the lifestyle stuff, is to take your foot off the gas.
Ideally, yes.
Yeah.
We're moving from static measurements to velocity measurements. If you change your lifestyle today, Dunedin pace can tell you pretty quickly if you've successfully slowed down your rate of aging.
It's empowering, but also a little terrifying. It's like having a dashboard for your own mortality.
Information is power. Without the dashboard, you're driving blind.
Speaking of driving blind, we have a lot more to cover. We need to talk about the zombie cells that might be eating you from the inside, and we have a deep dive into the economics of all this. What does a world without aging look like for your wallet? But first, if you are enjoying Tomorrow Unveiled, we have a small favor to ask.
If you are listening on a podcast service like Apple Podcasts or Spotify, we'd be incredibly grateful if you could leave us a rating and review for Tomorrow Unveiled. It truly helps us climb the charts and reach new listeners who are just as curious as you are.
And for our friends watching on YouTube, if you're finding this insightful, please take a moment to like this video, subscribe to Tomorrow Unveiled, and consider hitting that new hype button to help the algorithm find us. And of course, turn on those notifications so you never miss an update on the future.
Now, let's talk about zombies.
Yes, zombie cells. The scientific name is senescent cells. These are the cells that stop dividing but just won't die.
They're essentially retired cells that refuse to leave the office and instead just sit there causing trouble. They accumulate as we age and they secrete inflammatory chemicals, what we call the SASP phenotype, that damage healthy cells around them.
So they're toxic coworkers that ruin the productivity of the whole department.
A very apt analogy.
Yeah.
Now, for the last few years, there has been a lot of hype around senolytics drugs designed to kill these zombie cells. But the sources point out a major limitation with the first generation of these drugs.
Right. The research team noted that the previous treatments were only clearing about 30 to 70% of them. There was a resistant fraction.
The stubborn ones that just wouldn't die.
Exactly.
And the new breakthrough this week involves a class of agents called Senosensitizers.
Senosensitizers. It's a mouthful. How do they differ from the old drugs?
Think of the old drugs like a carpet bombing campaign blunt, and somewhat effective but easy for some cells to hide from. Senosensitizers work more like a Trojan horse or a false flag operation.
A false flag? How so?
Our research team found that if you use signals that mimic a viral infection, specifically what are called pathogen-associated molecular patterns, you can trick these resistant zombie cells. The signals make the zombie cells panic and reveal themselves. They drop their defenses because they think the body is under attack.
So we trick them into coming out of the bunker.
Precisely. Once they reveal themselves, they become vulnerable to the body's natural immune system or to the senolytic drugs. It effectively flushes them out.
And getting rid of that resistant fraction is crucial because those are the cells driving systemic inflammation, right?
Correct. Inflammation is the fire that burns down the house. If you can lower that systemic inflammation, you lower the risk of almost every single age-related disease.
Okay, so we're polishing the DNA, we're flushing out the zombies. Let's talk about the systems that keep the machine running. Metabolism. We have to talk about the drugs that have taken over the world. GLP-1 agonists.
The weight loss drugs.
The weight loss drugs.
Yeah.
They have been the story of the decade so far.
But the conversation is shifting. We aren't just viewing them as weight loss drugs anymore. They are being viewed as longevity drugs because of the massive improvement in cardiovascular health.
But, and there is a massive but, here in the research, there is a hidden risk that I don't think enough people are talking about.
It is a significant one: sarcopenia, muscle wasting.
Right.
When people lose weight rapidly on these drugs, the data shows that anywhere from 15 to 40% of that lost weight can be lean muscle mass.
That is huge. If you're in your 60s or 70s, muscle is your life insurance. It's what protects you from falls. It regulates your glucose. You can't afford to lose 40% of your engine.
Exactly. Frailty is a major killer. When you suppress appetite that aggressively, you often end up in a protein deficit. The body starts eating its own muscle for fuel, so the expert consensus is shifting, and aggressively.
You can't just sit on the couch and wait to get thin.
You can't. You need a high-protein diet to signal muscle retention and, non-negotiably, a resistance training protocol. You have to lift heavy things. You have to give the muscle a reason to stick around.
Otherwise, you end up skinny fat, which might look better in clothes, but is biologically very fragile.
Precisely.
Now, staying on the theme of inflammation, let's move from muscles to mouths. This was the weird but true fact in the stack for me. The oral microbiome. I know gut health is huge, but mouth health.
It's incredibly overlooked. There is a direct, measurable link between gum health and brain health.
The sources mentioned gum disease is linked to white matter damage in the brain. That is terrifying. How does that even happen?
It's the inflammation pathway again. The blood-brain barrier isn't as impenetrable as we used to think. Bacteria from the mouth, specifically the pathogens involved in gum disease, can enter the bloodstream and cause low-grade inflammation that eventually affects brain tissue.
So when the dentist lectures you about flossing, they aren't just trying to save your teeth, they're trying to save your brain.
The oral microbiome is becoming an actionable metric. We might see a future where dentists are the first line of defense against neurodegeneration.
So flossing is literally brain protection. I guess I'm buying more floss today.
I would argue it's one of the easiest high-return investments you can make for longevity.
Speaking of investments, let's zoom out a bit. We've talked about the biology, the hardware, but what about the software, the psychology? Because it turns out how you think about aging changes how you physically age.
This is fascinating, and it's often dismissed as woo-woo, but the biomarkers back it up. The research shows that worrying about aging, stressing over every wrinkle, checking the mirror obsessively actually accelerates biological aging markers.
It's a cruel irony. You worry about getting old, so the stress makes you get old faster.
Cortisol is a powerful chemical. Chronic stress suppresses the immune system and increases inflammation. So Having a positive or at least a relaxed attitude toward the passage of time is actually a biological intervention.
That's easier said than done when we just told everyone they have zombie cells eating them and their gums are attacking their brains.
True, but the goal is agency, not anxiety. Knowledge should be empowering. You have tools now, and you have your genetics.
That was another big stat this week. A new study suggests genetics might account for 50% of lifespan heritability. I thought it was much lower, like 20 or 30%.
We used to think that. The new data suggests it's higher. But don't misinterpret this. It doesn't mean you were doomed if your parents didn't live to 90.
Right, it's not a death sentence.
No. It just emphasizes the importance of knowing your ageotype.
This was a new term for me, ageotype.
It's the idea that people age differently. The study identifies 4 main pathways: metabolic, immune, hepatic, which is liver, or nephrotic, kidney. You might have the heart of an ox, but your kidneys are aging twice as fast as the rest of you.
So if 50% is the hand you're dealt, the strategy is knowing which cards are weak. If I know I'm a metabolic ager, I focus entirely on diet and glucose control.
Exactly.
If I'm an immune ager, maybe I focus on inflammation and those zombie cells.
Exactly. Personalized medicine is the only way to play the hand well.
And playing that hand better is going to be worth a lot of money. We have to touch on the economics of this, the longevity dividend.
The numbers are staggering. Extending healthy human lifespan by just 1 single year across the population would generate $38 trillion in economic value.
38 trillion, that's hard to even conceptualize. Where does that value come from? Is it just people working longer?
That's part of it, retaining wisdom and experience in the workforce. But the bulk of it comes from cost avoidance. Think about the cost of end-of-life care: nursing homes, chemotherapy, dialysis, Alzheimer's care.
Trillion-dollar drains on the economy.
Right. If you can delay the onset of those diseases by even 1 year, the savings are astronomical.
It makes sense. We currently spend almost all our healthcare money in the last 6 months of life trying to fight a losing battle.
Exactly. Shifting that spend to prevention and keeping people functional is the ultimate arbitrage. The longevity market itself is projected to pass $10 trillion by 2030, but the societal value is vastly larger.
So what does this all mean? We've covered a massive amount of ground today. Let's try to synthesize this. What are the big pillars here?
I see 3 main takeaways from this great inflection. First, we have moved from treating symptoms to treating the root cause, the information loss. We can now polish the scratched CD of our DNA with partial reprogramming.
We're fixing the code, not just patching the software.
That's a great way to put it. Second is visibility. We aren't flying blind anymore.
Right. AI tools like Brainy-IC and biomarkers like Dundon Pace allow us to see aging in the brain and body long before we feel it. We have a speedometer now.
And third is the shift in goalposts. We're moving from lifespan, just years alive, to healthspan, years functional. It's not about immortality. It's about vitality.
It's about dying young as late as possible.
That's the phrase, yes.
It's a completely different way of looking at life. And honestly, it changes the ethical landscape too.
It does. And it raises a really profound quote that I think we need to leave the listeners with. If we connect this to the bigger picture, if aging is effectively a medical condition, a breakdown of information and cellular machinery rather than just natural destiny, well, the moral baseline flips. Well, historically we've asked, should we stop aging? Is it playing God? But if aging is the root cause of cancer, dementia, heart disease, and suffering, and if we have the tools to treat it, the question isn't, should we stop it? The question becomes, how can we justify not treating the suffering caused by biological decline?
That is a heavy thought. If the medicine exists, is it unethical to withhold it? Is allowing someone to age essentially the same as refusing to treat an infection?
Exactly.
That is something we want you, the listener, to mull over. We want to hear from you on this one.
We love hearing your thoughts. Whether you're on YouTube or your favorite podcast app, leave a comment and let us know what you think about this shift.
Specifically, would you take a treatment to reverse your biological age, or do you think aging is a necessary part of the human experience? Let us know in the comments. We read them, and we might feature your take on the next Tomorrow Unveiled.
It's going to be a fascinating debate.
It certainly is. Thank you for joining Tomorrow Unveiled today. We hope you feel a little more informed, a little more optimistic, and maybe a little more polished.
Stay curious.
And be sure to turn on notifications so you never miss an update on the future. See you next time.